In this video, I will be teaching you what an inverse of a matrix is and how to find it using elementary row operations. Before we have the formal discussion of what an inverse of a matrix is, it is important that we see how it is related with operations on real numbers. Consider the real number equation ax is equal to b. To solve this equation for x, we multiply both sides of the equation by a to the negative 1. Provided that a is not equal to 0. A to the negative 1 is usually denoted by 1 over a, as this is the reciprocal of a. In other words, to find the value of x, we divide both sides of the equation by a. So we cancel this. Therefore, x is equal to b over a. The number a over 1, or a to the negative 1, is called the multiplicative inverse of a, because if we multiply a and a to the negative 1, the result is equal to 1, which is the identity element for multiplication in real numbers. To illustrate this, consider the equation 2x is equal to 4. To solve the equation, we need to multiply both sides of the equation by 2 to the negative 1. Or 1/2, which is the inverse of 2. Solving the equation, we get x is equal to 2. If we multiply 2 and 2 to the negative 1, then the result is equal to 1. The definition of a multiplicative inverse of a matrix is similar to this. An n by n matrix A is invertible if there exists an n by n matrix B such that A times B is equal to B times A is equal to I sub n, where I sub n is the identity matrix of order n. The matrix B is called the multiplicative inverse of A. A matrix that does not have an inverse is called non-invertible. It is important to take note that non-square matrices do not have inverses. To see this, note that if A is of size m by n and B is of size n by m, where m is not equal to n, then the products AB and BA are of different sizes and cannot be equal. Moreover, the inverse of a matrix is unique. So, how do we find the inverse of a matrix? You may use the elementary row operations. Let's consider the example 3.14. Find the inverse of the given matrix: 1, 4, negative 1, and negative 3. So the first thing that we will do is we will write the matrix. That is 1, 4, negative 1, and negative 3. After copying all the elements of our matrix, we will now create an augmented matrix. And on the other side of the matrix, we will write an identity matrix of the same size of our original matrix. So it is a 2 by 2 identity matrix. That is 1, 0, 0, 1. Our goal here is to convert the left side of the augmented matrix to an identity matrix using elementary row operations. Once we're done, the right side of the augmented matrix is the inverse of the original matrix. Let's do that one. So we will change this one to 0. And to do that, all we need to do is to perform this elementary row operation, that is R2 plus R1. So we will have our new matrix. That is, for the first row, we will not do anything. So that is 1, 4, 1, 0. But for the second row, so R2 plus R1, that is 1 plus negative 1 is 0. And negative 3 plus 4 is positive 1. Here, 0 plus 1 is 1. And 1 plus 0 is 1. Finally, we will need to change this 1 to 0. And to do that, we will try to perform an add row function. So that is R1 minus 4R2. With this, we have 1 minus 4 times 0, that is still 1. And 4 minus 4 times 1, that is 0. 1 minus 4 times 1 is negative 3. And 0 minus 4 times 1 is negative 4. For the second row, all we need to do is to copy all the elements. Therefore, the inverse of the given matrix is negative 3, negative 4, 1, 1. To check if our answer is correct, we can perform matrix multiplication on the two matrices. Let's do that. That is 1, negative 1, 4, negative 3. That is our original matrix. Times the inverse, which is a negative 3, negative 4, 1, 1. So let's perform a matrix multiplication. That is, for this cell, that is 1 times negative 3 plus 4 times 1. So that's 1 times negative 3 plus 4 times 1. And that is equal to negative 3 plus 4, which is equal to 1. Next, for this cell, so that is negative 1 times negative 3 plus negative 3 times 1. So this is equal to 3 minus 3, which is 0. So for this cell, that is 1 times negative 4 plus 4 times 1. And this is equal to negative 4 plus 4, which is 0. And for the last cell, so that is negative 1, this one, times negative 4 plus negative 3 times 1. So this is 4 minus 3, which is equal to 1. So this is the identity matrix, but we need to do the other way around. So let's perform the other way. So again, we are to expect an identity matrix. So for the first cell, this one, that is negative 3 times 1 plus negative 4 times negative 1. So this is equal to negative 3 plus 4, which is equal to 1. For this cell, that is 1 times 1 plus 1 times negative 1. So this is equal to 1 minus 1, which is equal to 0. for this cell, that is negative 3 times 4 plus negative 4 times negative 3. So this is equal to negative 12 plus 12, which is equal to 0. And for the last cell, we have 1 times 4 plus 1 times negative 3. So this is equal to 4 minus 3, which is equal to 1. So both ways generated an identity matrix. Therefore, this is the inverse of our original matrix. Let's consider another example. Find the inverse of the given matrix in example 3.15. So the first thing that we will do is we will copy the matrix. That's 1, negative 1, 0, 1, 0, negative 1, negative 6, 2, 3. Then we have the augmented matrix. On the right side, we will create a 3 by 3 identity matrix. That is 1, 0, 0, 0, 1, 0, and 0, 0, 1. So the first thing that we need to do is to make this 0 and 0. So for this to become 0, all we need to do is to do this operation. That's R2 minus R1. And for this to be 0, all we need to do is to perform this operation. R3 plus 6 R1. So let's perform the operation. For the first row, we will not do anything. So all we need to do is copy. That's 1, negative 1, 0. And here, that's 1, 0, 0. So let's start with the second row. That's 1 minus 1. That's 0. 0 minus negative 1 is positive 1. Negative 1 minus 0 is negative 1. 0 minus 1 is negative 1. 1 minus 0 is 1. And 0 minus 0 is 0. For the third row, we have negative 6 plus 6 times 1. That is 0. 2 plus 6 times negative 1. So that's 2 minus 6. That's negative 4. 3 plus 6 times 0 is still 3. 0 plus 6 times 1 is 6. 0 plus 6 times 0 is 0. And 1 plus 6 times 0 is 1. Next, we need to convert this to 0 and 0 also. So to do that, for this to become 0, all we need to do is to perform this operation. R3 plus 4R2 because it's 1. And for this to be equal to 0, so we will use or we will perform this operation, that is R1 plus R2. So let's continue the process. So for the first row, we will do something about it. But for the second, we don't. So we will copy. That is 0, 1, negative 1. We have negative 1, 1, and 0. So let's start with the first row. So for the first row, the operation is R1 plus R2. So 1 plus 0 is 1. Negative 1 plus 1 is 0. 0 plus negative 1 is negative 1. 1 plus negative 1 is 0. 0 plus 1 is 1. And 0 plus 0 is 0. So for R3, we have 0 plus 4 times 0 is 0. Negative 4 plus 4 times 1 is 0, because that's negative 4 plus 4. 3 plus 4 times negative 1, so that's 3 minus 4. So that's negative 1 also. And continue the process. That is 6 plus 4 times negative 1, so that is 2. Then 0 plus 4 times 1 is 4. And 1 plus 4 times 0 is 1. To make things simple, again, our objective is to make this as an identity matrix. We will multiply the third row by negative 1. That is negative R3. So we will not do anything on the first and second row. So that is 1 rather. 0, negative 1, 0, 1, 0. This is 0, 1, negative 1, negative 1, 1, 0. And here, this is 0. This is still 0. So negative 1 times negative 1 is positive 1. This is negative 2. This is negative 4. And this is negative 1. Now, we will try to change this one to 0, 0. So we can do that by performing this operation. That is R1 plus R3. And similarly, that is R2 plus R3. So for the third row, we will not do anything. So we will just copy all the elements. It's negative 2, negative 4, and negative 1. And for the first row, that is 1 plus 0 is 1. 0 plus 0 is 0. And negative 1 plus 1 is 0. For the other side, that is 0 plus negative 2 is negative 2. 1 plus negative 4 is negative 3. 0 plus negative 1 is negative 1. So for the last, R2 plus R3, so 0 plus 0 is 0. 1 plus 0 is 1. Negative 1 plus 1 is 0. So we now have an identity matrix on the left side. So let's continue on the right side. That is negative 1 plus negative 2 is negative 3. 1 plus negative 4 is also negative 3. And 0 plus negative 1 is negative 1. Therefore, the inverse of this matrix is equal to negative 2, negative 3, negative 1, negative 3, negative 3, negative 1, negative 2, negative 4, and negative 1. You may check your answer by multiplying this to this and interchange their position. If you get an identity matrix for the two operations, then your answer is correct. Take note that not all square matrices possess inverses. Consider the given matrix in example 3.16. Show that the inverse of the given matrix below does not exist. So the first thing that we will do is we will copy the original matrix. It is 1, 3, negative 2, 2, negative 1, 3, 0, 2, negative 2. Create an augmented matrix, and here, identity matrix will be placed. That is 1, 0, 0, 0, 1, 0, 0, 0, 1. So we will perform elementary row operations, change this one to 0 and 0. So to make this 0, all we need to do is to perform this operation. That is R2 minus 3 R1. Here, to change this 0, all we need to do is to do this. That's R3 plus 2 R1. So let's perform these operations. For the first row, we will not do anything, so we will copy all the elements. That's 1, 2, 0, 1, 0, 0. So for the second row, we will use this operation. That is 3 minus 3 times 1 is 0. Negative 1 minus 3 times 2, that's negative 6. So it's negative 7. 2 minus 3 times 0 is still 2. 0 minus 3 times 1 is negative 3. 1 minus 3 times 0 is 1. 0 minus 3 times 0 is 0. For the third row, we will use this operation. So that is negative 2 plus 2 times 1 is 0. 3 plus 2 times 2, that's 4, is 7. And negative 2 plus 2 times 0 is negative 2 still. 0 plus 2 times 1 is 2. 0 plus 2 times 0 is 0. And 1 plus 2 times 0 is 1. So to make things simple, what I will do is convert this to positive 1. So that is negative 1 over 7 R2. This will be equal to, for the first row, nothing will happen. So we will copy. So 1, 0, 0. Here, this is 0. So negative 7 times 1 over 7, negative, is 1. This is negative 2 over 7. This is positive 3 over 7. This is negative 1 over 7. And still, this is 0. And here, this is 0, 7, negative 2, 2, 0, 1. Now, let's try to change this one to 0. I will not change this one to 0 because something will happen. And let's find it out. So this is, to change this one to 0, all we need to do is to perform this operation. R3 minus 7 R2. So for row 1, we will not do anything. That is 1, 2, 0, 1, 0, 0. Here, this is 0, 1, negative 2 over 7, 3 over 7, negative 1 over 7. This is 0. And for the third row, that is 0 minus 7 times 0 is still 0. 7 minus 7 times 1 is 0. Negative 2, I will write this one. This is negative 2 minus 7 times negative 2 over 7. So this is equal to negative 2. So this will be cancelled out. And From negative, negative. So this is positive 2. So this is equal to 0. This is equal to 0. Now here, this one, let me just write this. So this is 2 minus 7 times 3 over 7. So this will be cancelled. So this is negative 2 minus 3. So this is negative 1. So negative 1. So 0 minus 7 times negative 1 over 7. So this will become positive 1. And just to illustrate this one. So 0 minus 7 times negative 1 over 7. So this will be cancelled. So this is equal to 0 plus 1. So positive 1. And finally, 1. This is 1 minus 7 times 0 is equal to 1. So notice that on the left side of our augmented matrix, we were not able to generate an identity matrix. If that is the case, then the given matrix has no inverse. So that is how we show if the given matrix has no inverse. If we cannot generate an identity matrix on the left side of our augmented matrix. Some important properties of inverse matrices are listed below. If A is an invertible matrix, K is a positive integer, and C is a scalar not equal to 0, then the inverse of A, denoted by A to the negative 1, A to the K, and the transpose of A, denoted by A to the T, are invertible, and the following are true. So the first one is this one. So the inverse of the matrix is equal to the original matrix. This one. The inverse of A to the K is equal to the inverse to the K power. Here we have another property, that's the inverse of the product of the scalar C and matrix A is equal to the reciprocal or the inverse of the scalar C times the inverse of matrix A, where C should not be equal to 0 for this to exist. And finally, the transpose of A inverse is equal to the transpose of the inverse of A. So it is important to take note of this because if you encounter complex operations, properties are useful. So that's it for our video. Thank you very much for watching and have a good day.